Can you give us a little bit more detail about how do we look at constructing large problems like this and the structure of the three-computer problem that you talk about?
When you talk about Gen AI, there's three different evolutions, if you will. There was the industrial AI, which is or pioneering AI, meaning that a lot of companies are building their foundational models and that development. And then there's enterprise AI, where they're taking these foundational models and making chatbots and tools and applications using those foundational models. And what we see next is what we call physical AI. Physical AI meaning that AI inferencing model that you've created now resides it's embodied in a physical environment. And that could be a tractor, it could be a robot, it could be a train. So that's what we mean. So in the three-computer problem, what we're talking about is to make that reality happen, you're going to need one computer, and I use the word computer, but one computing environment that is going to be where you train the model, you build the model. The next environment is that it's a simulation environment where you actually simulate the operation of that model. Part of it could be you need simulation to maybe help you create the data to do the training for the AI model. But that simulation will allow you to train the model in a simulated environment. Just like if you were in the Matrix, you don't know if you're in the Matrix. So just like that, that model doesn't know that it's not in a real environment, but it's operating as if it's seeing different conditions and being trained and inferencing on that model. And you optimize that model to get 98, 97, 98, 99% efficient accuracy. And once you have that, then you have full confidence in deploying that in your actual environment. So that way you have a very high percentage of success, especially when you're going, in brownfield environments where your tolerance for failure is very low because you want to make sure you integrate properly in that environment. You don't want to be testing in that environment continuously. You want to simulate that and then run in that physical environment. So when we talk about the three-computer problems, it's actually what's your development cycle and optimization cycle that gives you the best results.
As models become more and more commodities, how do we make sure that we have efficiency in our data centers? And this is where Azure really shines, because we have the work that we do to make the compute itself very efficient. But we cannot do that without having partners like NVIDIA, and without having data. The AI and the compute is all going to be completely useless. And so with Hitachi and the combination of the data coming in from OT and IT, and the marriage of that with the efficient data centers that we provide on top of Silica like NVIDIA, I think this is what is going to really democratize AI for the world and make it. So we have grand ambitions with AI, right? Across the industry, we have grand ambitions with AI. NVIDIA has grand ambitions. Microsoft has grand ambitions with AI. And in order to really make it true, in order to really take us to the next stage in the era of AI, I think this is where having access to that sort of data, which is going to make our AI more and more accurate, to the point that you just made, and also to marry that with the efficiency and the large-scale capacity that we're able to provide, that is where we can push the humanity forward. Sometimes when I talk to leaders across the industry, a question that comes up is how much of this AI thing that we're talking about, how much of that is really going to come true, and how much of that is going to, is just a bubble. And I strongly believe, based on the data that we're seeing in terms of the customer growth and the customer demand and the use cases across everything from automation to prediction to products and services, the demand that we're seeing, this is going to be very real. What are the important ingredients for us to be successful as leaders? And I'm very happy that we're all, Hitachi, Microsoft, NVIDIA, are all leading the AI revolution for the industry, for humanity. And I'm very proud to be part of that revolution, and very humble. I'm very grateful to be part of that revolution as well. I think what can make this successful for the world is that combination of data that we are getting from sensors, that we are getting from the world, married with an efficient AI infrastructure, an efficient data center that is large scale, with Silica that is powerful. So I think this is the combination is what is going to make AI successful for the world.
Raji, you asked me about how we view partnership, right? Fundamentally, we want to make sure that all the investments that you make, the problems you solve, the mistakes you've seen others make, we don't want to be able to do it ourselves, right? And as we start looking at our AI journey, we fully realize that foundation, like you mentioned about data, that's going to be foundational. The learnings, the infrastructure, the security, cybersecurity that platforms provide for us to reliably, safely connect, access our data, store our data, manage our data, and also from a data governance perspective, okay, what is it that we can get from our customers? What is it that we cannot? And as a large global organization, there's also regional, country-specific data sovereignty roles, and companies like yourselves have solved this problem, right? We want to tap into the technology capabilities that you have. We want to tap into the learnings that you have, so we don't have to go through the steep learning curve to deploy these IT into OT solutions at scale for us to leverage the power of AI. When it truly needs to scale at an enterprise level, right? The architectural choices that we need to make between the three of us, right? What are the constraints in an OT environment? What can we do on the edge? What can we do in the cloud? And obviously, it's not just going to be a single archetype of an architecture. There's going to be multiple reference architectures. And the learnings from what you have done, right? The investments that we're making to make sure that our architecture, our pathway is secure, robust, because more than anything else, right? Our solutions have to be reliable.